Hey everybody, in this lesson we are going to do systems of equations, and these lessons all happen kind of leading up to this. So as a quick warm up, let's look over what we went over each of these days. On the first lesson, we went over slope, and we should all remember what the slope formula is. You have been doing slope since at least, sorry, it's blurry, at least algebra 1, I would hope. So slope, we use m. And the formula is y2 minus y1 over x2 minus x1. It's your rise over your run. It's your rate of change. Lesson 2, we were graphing lines and we used slope-intercept form. Slope-intercept form was y equals m x plus b. And again, m is your slope. It's your rise over your run. And the b is your y-intercept. Y goes up high. It's the axis that goes up and down, and that's how we would graph. In lesson 3, we did point slope form, which is y minus y1 is equal to m times the quantity of x minus x sub 1. Point slope form is pretty nice because you just plop a point in for the x1 and the y1, and you plop in the slope, and you leave it alone. You do not do anything else. If you needed to change from point slope form to slope intercept, y equals mx plus b, you could do that. You would distribute first, then bring over that y, combine like terms, boom, you're done. Okay? Parallel and perpendicular lines are lesson 4. Parallel lines, that's the symbol. Perpendicular lines, that's the symbol. Here, the slope of the first line is equal to the slope of the second line. In perpendicular lines, the slope of the first line is equal to the opposite reciprocal. Opposite means change the sign. Reciprocal means flip it over. And this is how we write that as a notation. You could write it like this, or we can just write in parentheses op, OPP, REC for reciprocal. I'm just abbreviating. So as an example, we would have, say, 2/3 would turn into -3/2. If we had a 4 or a -4, that would turn into a +1/4, and so on. All right, so that's what we did there. Today, lesson 5, system of equations. We should be able to answer the following questions. What are you finding when you solve a system of equations? We are finding what points they intersect at. At the end of the day, that's the nitty-gritty of it. What points the equations, and we're going to focus on just linear equations, what points the equations intersect at. Also, if it's a word problem, you're finding the x and the y that satisfy both equations, that make both situations true. Okay, that's what solving a system does. It solves the problem for everybody. So it works for this equation and this equation, makes them both happy. It is a solution, and it would be a coordinate point if we're dealing with two variables, an x and a y. Visually, graphically, it's the points that the equations are going to intersect at or overlap at. What are the 3 possible outcomes? Well, I'll show you a quick sketch. One possible outcome, and this is just for linear, okay, if you have 2 lines. One possible outcome is one point of intersection. That's going to happen as long as the lines have 2 different slopes. If the lines have 2 different slopes, they have to cross eventually. One point of intersection. What if we have parallel lines? 0 points of intersection is another possible outcome. So they will have the same slope, but different y-intercepts. Very important. And the third one is you have a line and the other one is exactly the same line on top of it. Infinite. Points of intersection. Another way we could say points of intersection is just solutions. Okay, these are also solutions. All right, so infinite solutions. Next, what are the 3 methods that we will use to solve systems of equations? 1, first one we're going to do is graphing. It's just the visual way of figuring this all out. Not the best, because if they intersect at decimals, you can't really know that. The second way we're going to look at is elimination. And the third way we have on our list is substitution. These are more algebraic methods. I don't know why I was going to make that plural. Substitution and elimination. So these are solving algebraically. You're going to really just do some math on your paper. Algebraically. Okay? So we should have all this jotted down. These are our notes to get us started. I'm going to do an example, show you how to do it, and then you will be responsible for examples after that. So you'll press pause after I do one with you, and then you're going to try a few on your own. And then when you're done, you hit play, and I'll do another type. I'm not going to do all of them. You'll see what I mean. So here, I'm going to do number 1 with you. Then you're going to go ahead and do numbers 2 and 3. And then I might just chat with you about 5 and 6, but you're going to do 5 and 6 on your own. But if you want advice for 5 and 6, you're going to unpause the video and I'll give you a little advice, okay? This equation here is already written for us in lovely y equals mx plus b form. Both of them are pretty sweet. This could have a little curly bracket next to it. That's usually how you would see it. What I'm going to do from here, b, negative 2 is my y-intercept, plot a point, very nice. My slope over here is negative 3 over 2. Watch out for those negatives when they're in front. They kind of blend in with the fraction bar sometimes, so just watch out for that. That means that I would normally go down 3, m equals negative 3 over 2. Down 3 and right 2. My graph paper is a little cut off, so I'm just going to, in my head, think of it as 3 over negative 2. I'm going to go up 3, left 2, up 3, and left 2. Up 3, left 2. So then I'm drawing my line, connect your dots, arrow at the end, and then here as well, connect the dots, arrow at the end. Hopefully my solution is going to be here in this window. We'll see. Next, graphing that line. 3 is the y-intercept, 1, 2, 3. If you're graphing this and making your own graphs, if you don't label your tick marks or put tick marks, it's wrong. Okay, I need to know that you are plotting your intercepts at the right place and that you're doing your slopes correctly. You can't just draw a random graph without labels, okay? Now my slope for this one is negative 1 over 4, or I could think of it as 1 over negative 4. Here I'm going to think of it as down 1 and right 4. If I think of it this way, up 1 and left 4. Wow, that worked out very nicely. It crossed through that point perfectly. So there we go. If you have a ruler, it's even better. There we go. So winner, winner, chicken dinner. You're not done. Solve each system. You have to solve. What's the answer? You have to write down what the answer is, and we must write it as an ordered pair. What's this ordered pair? Left 4, up 4. My solution is negative 4, comma 4. And then I'm going to circle it with a little cloud, happy cloud, and call it a day. So that was how you could do example number 1. I did that with you. I hope you followed along and copied. If you needed to pause, rewind, replay, whatever you needed to do, then, do what you have to do to get that all copied down and done. And then you're going to press pause, and I want you guys to work on at least 2 through 4. And if you could power through to 5 and 6 also, go ahead and do those. Otherwise, you will unpause the video to get some advice about numbers 5 and 6. If you're watching right now, that means that you are not paused, and that means you're ready to talk about number 5 and 6. When you're doing these, they're in standard form. We need to turn them into slope-intercept form, so we're going to rearrange a little furniture. I'm going to take this 5x minus 4y equals negative 16. I'm going to subtract that 5x from both sides because I need it to become my mx. All right? Here it eliminates, adios. What am I left with? I have negative 4y equals. Now I'm going to stick the one with the x in front and then the one without the x after. Remember, your goal is to make this look like mx plus b. So this will be negative 5x and minus 16 because they both have negatives in front of them. Then I'm really close to y equals mx plus b, but this y has a negative 4 in front. So I'm going to divide everybody by negative 4. That means I'm left with y equals a negative over a negative is positive 5 over 4x. Negative over a negative is positive, and 16 over 4 is 4. So that's my first equation. I'll do the work for the other one, just like this one, get my other equation and graph them from here. That being said, +4 is my y-intercept. I'm just going to graph one of these lines. You're on your own for the other line and then to do the other one. Then 4, and then I could go up 5 over 4, or I could think of the m as being -5 over -4. We spoke about that on lesson 1 or 2. So I could also go down 5 and left 4, get that dot, get myself a ruler and draw myself a really nice line. And there we go. Remember, if you graph and you get parallel lines, your solution is no solution. If you graph, oh, there's my little parallel lines. If you graph and you get a line and then the other one's the same line on top of it, your answer is not an ordered pair. You would just put infinite solutions, okay? So just be careful of that. Now I'm going to show you how to solve a system by elimination. I'm going to do one example and then you're going to do 3 on your own. To solve by elimination, we want to get 2 of my letters over here, to x or y, to have the same coefficient, the same number in front. So if I wanted to make this 7y and this -7y, I can do that. They could be positive and negative, both positive. You'll just adjust what you do. I want this to have a 7 in front, so I need to multiply this whole entire equation by 7, so times 7. -5x plus 7y equals 18 stays the same. And then -28x minus 7y equals 7 times 12 is 84. And it'll be -84. Bam, there I go. So elimination, once you have these two numbers either the same or technically opposites, in this case, one's negative and one's positive. What we're going to do is we're going to, since they're opposite, I'm going to add them together. What's -5 plus -28? A negative and a negative adds to give me another negative. That's going to be -33x. When I add -7y and +7y, they eliminate and they're gone. And then I have 18 plus -84 or -84. So if I subtract those, 84, 74, 64, I'm going to get -66. Keep going to solve for x. I'm going to divide by -33. This is just basic equation solving from Algebra 1. And I'm going to get x equals +2. That's just the x value of where your points intersect. To get the y value, you take your x and fill it in. So you'll get -5 times, I'm going to fill it into either equation, whatever one you want. I'm going to do the top one. Plus 7y is 18. -5 times 2 is -10. Plus 7y is 18. I'm going to add 10 to both sides. I'm going to get, I'm running out of room. I apologize. So hopefully you're a little neater than me. 7y equals 18 plus 10 is 28. Divide by 7. We get y equals 4. But that's not how we leave our answer. We write it as an ordered pair. 2, 4. And there's our solution. One last thing for you guys to write down as notes before you guys press pause and finish this up is if you end up eliminating everything and you get a true statement like 2 equals 2, that's weird. How are you solving for x? You put infinite solutions. And if you get a false statement like 2 equals 3, that's not true. How do I solve? You just put no solution. So go ahead and finish up to number 10 for today, and we're going to move on to solving by substitution tomorrow. I hope this was helpful. Finish up to number 10 and have a great day.